All right, so now we're going to have forms that are of the type 0 times infinity. And if we think about that, if we go as we get closer and closer to 0 and take the square of that, that's going to give us 0. And as we get closer and closer to 0 for ln t, that's going to go to infinity. And so that's going to be basically our 0 times infinity. And so what we need to do is convert it to one of these types. And so what I'm thinking is if we take this and take it to the denominator, t to the negative 1/2, then let's see what we get here. So that gives us limit as t approaches 0 from the right of ln of t over t to the negative 1/2. Okay. Well, if we plug in that 0, that's going to be infinity on the numerator, and a super small number to the negative square root of a negative half. Well, let's look at that. So let's go to here. Let's clear that. So if we take a super small number, say 10 to the negative 99, and we want to raise that to the negative zero point 0.5, oh, that's a pretty large number. So we're going to call that infinity. So it's going infinity over infinity. Okay. Now that means we need to use L'Hopital's rule and take the derivatives. So that gives us a limit as x approaches 0 from the right of 1 over t over, and then that's going to be negative 1/2, and then t to the negative 1.5, because we subtract 1, we get negative 1.5. Okay. And so what does that all equal? That's going to be the limit of x going to 0 from the right of t to the negative 1. So we'll just put it all in one thing so we can't get it confused. And then as t to negative 1.5. Now I notice here I've got t's in numerators and denominators. So what I'm going to do is I'm going to convert it to one form. If I take this to the numerator and make it a positive 1.5 times that, that's going to give me t to the 1/2. So that's going to give me a limit as, I guess we're switching again. That's a t, and t goes to 0 from the right. And that's going to be a t to the 1/2. And it's going to be over a negative 0.5. So if we plug in 0 here from the right, that's going to be a very, very small number, and that's going to give us over that. And so a very small number divided by that will give us basically 0. Okay, so that's what we'd end up with this one. All right, what about the next one? Well, here we're going to take and plug in infinity. So that's going to be infinity here. And e to the negative infinity is going to be 0. So we're going to have an infinity times 0 format. And so we still need to get it to one of those because we can't do anything in this format. So I would suggest we have a negative here. So let's take it down. Okay, we're going to change to t's again, it looks like. Well, that should be an x. All right, so they have a typo or something here. So let's write it now as x approaches infinity. And now again, like I said, let's take that e to the negative x down and make it e to the positive x. Now if we plug in infinity here, well, that's going to be infinity over infinity. Well, we can work with that. And so that's going to be this one. So that means we just take the derivative of both of those and then take the limit. So that's going to give us a limit as x approaches infinity of 2x over e to the x. Okay, well, that's not hard. We can simplify that. Well, that gives us what? Well, guess what? That gives us infinity over infinity again. And we cannot reduce. And so what does that mean? Well, it means we need to apply L'Hopital's rule one more time. Remember, if we don't get it to first time and we can't reduce anything, then we do L'Hopital's rule one more time. And so when we do that, that's going to give us limit as x approaches infinity of, well, the derivative of that's going to give us 2, derivative of that's e to the x. Well, that gives us basically, 2 over infinity. Well, a very small number divided by a very large number, well, that's going to give us 0. Okay. And so that was the key. So we had to do L'Hopital's rule twice. We had to do it once, twice, and then we got our 0. Now, if we think about, I think the last one, it was something like a 12x to the third over a 15x squared. We could have done, a derivative again, and then we could have got to a point where we'd have had to do a derivative 3 times. We'd had to do this one, and another one, because we would have got rid of, eventually we would have gotten rid of the denominator, and then that would have helped us to get to our value there. But we could reduce also. In this case, we can't reduce, and so we had to take that derivative one more time before we actually got that 0. All right, what about limit of t? This is supposed to be x again. Then we have x here. Yep. All right. So limit of 3x times 2 over e to the x. Well, let's plug in our 0. So that's going to be 3 times 0, and then 2 over e to the 0. Well, that's going to be 0 times 2 over 1. Well, 0 times 2, well, that's just 0. So that one, we really didn't have to do anything except for substitution. So sometimes we get lucky, and even though the problem looks like it might be more difficult, we can actually just do substitution, and we get what we need for the answer here. Okay. Now let's plug it in here. We want to plug in infinity. All right. So if we have our 0.6 and we raise that to, say, 10 to the 99, what do we get? Well, we're going to get 0. Okay. And so it's going to be basically 3 times 0 times. And if we plug in infinity here, the ln of, e to the 99 is going to give us basically, a big number. It's going to go to infinity as larger and larger we get. And so that 3 basically is nothing. That's going to be 3 times 0. So that's going to be our 0 times infinity in determinant form. Now, what can we do? Well, we could rewrite one of those into the denominator. So let's take this one, because it's easy to write a negative here compared to that. So let's say limit as x approaches infinity of 3 ln of x over 0.6 to the negative x. Okay. Now, if we plug in the infinity and 0.6 to the negative, 10 to the 99, that's going to give us, let's see, overflow. It's going to be infinity. It's going to be an infinity value. And ln of that, well, we already said before, when we take that ln, that's going to be infinity. So now we have it in the form that's indeterminate that we can work with. So what does that mean we have to do? We have to take this derivative, okay? So that goes and says, well, limit as x approaches infinity of 3 over x, because the ln of x is just 1 over x, and so we'll just have 3 over x in the numerator. Now the denominator. Okay, well, we're going to have to take the ln of that, and that's going to be the negative 1 in front of it. So it's going to be negative, and then ln of 0.6 times 0.6 to the negative x. Okay. Now that's going to be one form. Now, does this make sense having this at 1 over x here? I think what I'm going to do is, just for simplicity's sake, I'm going to say that's 3 over negative x ln 0.6 and times 0.6 to the negative x. Okay. Now, as x goes to infinity, this is going to go to infinity. Ln of 0.6 is just the number. And this, we said, is already going to infinity. So basically, what do we have then? And so we're going to have really just that small number, 3 over some infinity. And a small number divided by a huge number, guess what? We go to 0. Okay. And so that would be what it is. And really, there's still that limit here as x goes to infinity. And so then when we take that and derive that, that's going to 3. And we said, that one's going to infinity. That one's going to infinity. Infinity times, this number, that's still going to be infinity. And so 3 over that is going to give us a 0. All right, so let's pause there, and that's all I have actually. So hopefully that will help.